Welcome to Crosstalk Solutions. My name's Chris and this is UDM-Pro Complete Setup Video 5, where we're going to be setting up an IoT network with firewall rules. IoT network stands for Internet of Things. It's stuff like this smart Wi-Fi plug, or your smart refrigerator, or that mural frame that I have in the background of my videos, right? So any of these sort of smart connected devices. Now, the reason that you want smart connected devices isolated onto their own network is because of the threat of these devices being compromised. A lot of these devices phone home to like Amazon AWS services or phone home to the parent company that makes the device, and it allows you to have access to these devices from the outside world. So think of like an Ecobee thermostat, for instance. I have an Ecobee thermostat. I can affect changes to my thermostat from anywhere in the world because it is reaching out to a connected service, and having these IoT devices in their own segregated network really helps you not only control which devices are actually reaching out to the internet, but you are separating those devices from your more secure main LAN network where your photos and My Documents and all of the stuff on your regular computers are. So since we are talking about IoT and we're going to be digging into UniFi firewall rules, it is a perfect excuse to pour myself a beer, not to mention that it is late on a Friday afternoon right now. And I gotta say that all of the IoT devices in my house, literally every IoT device in my house, is on my IoT network. So I have Home Assistant on that network, all of my TVs and Rokus, everything, anything that's just one of those Internet of Things devices goes on the IoT network, period. One thing you might want to do is also have a separate network for surveillance cameras. So you can have an IoT network as well as a surveillance camera network. It's going to be the same exact concept for both of those types of, separate subnets. In this video, though, we're just going to do the IoT network. All right, so cheers to everyone out there. Before we hop into this video, though, like and subscribe to Crosstalk Solutions if you haven't already. It's absolutely free and it really helps out the channel. Also, follow me on Twitter at CrosstalkSOL, and if you'd like to buy me another beer, there's a link down below to do that as well. Okay, let's get started. Here I am at the dashboard of UniFi. I should say the new dashboard of UniFi Network. Now, since we want to create our IoT network as a corporate network and not a guest network, and we're going to be adding some firewall rules for that network, we can't do that in the new interface. We have to switch to the classic interface. So let's do that first. We're going to click Settings, System Settings, and then we're going to turn off the new user interface. And this is going to bring us back to the original or classic UniFi interface. So we need to start by creating our IoT network. So we're going to click Settings, and then we're going to click Networks, and we want to click Create New Network. It's going to be a corporate network, so make sure you choose that. We're going to call it Crosstalk IoT for Internet of Things. We're going to give it VLAN ID 20, and we're going to give it a subnet of 192.168.20.1/24. Click Update DHCP Range, and it pulls this subnet information down into your DHCP range down below. But we're going to change it to 2 through 254 so that we take advantage of the complete available set of IP addresses in this network. For the DHCP name server, we're going to say manual, and we're going to give it a couple of public IP addresses, 1.1.1.1 and 9.9.9.9. Now, both of those services are a little bit content filtered, but if you have something like OpenDNS, you might want to use that there instead. Okay, so that's it for our network setup. We're going to click Save. And now we have a new Crosstalk IoT network that exists on VLAN 20. Next, let's create a wireless network because most of these IoT devices operate wirelessly. So we're going to click Wireless Networks, and we're going to click Create New Wireless Network. We'll call this wireless network Crosstalk IoT as well. We're going to click WPA Personal for the security type, and we're going to give it a security key. You can choose to support WPA3 connections, but most of these devices are not Wi-Fi 6, so they're not going to be able to do any sort of WPA3. So for me, I'm just going to leave that off. Now when we want to choose the network, we're going to choose Crosstalk IoT because that's going to put any devices that connect to this Wi-Fi onto the Crosstalk IoT VLAN that we just created. VLAN, of course, stands for Virtual Local Area Network, and it just essentially means that we've got our LAN and then we've got additional separated LAN networks called VLANs or virtual LANs sort of stacked on top of the main LAN. Any switch port that we plug something into can be any one of those, as we'll show later in this video, or it can be all three of those, but a device is only going to be able to see your VLANs if it can understand VLAN tagging. And again, that's all a little bit complicated. I've done a number of videos on VLANs, but we're also going to dig a little bit into VLANs later on in this series. All right, opening up advanced options, you might want to consider only enabling the 2.4 gigahertz band for your IoT devices. Most IoT devices are only 2.4 gigahertz, and the ones that are, mixed mode, 2.4 and 5 gigahertz, they can do 2.4 gigahertz anyways. 2.4 gigahertz is going to have a little bit more of extended range for your devices, and you also wouldn't be cluttering up your 5 gigahertz spectrum for other devices such as your phones and tablets and laptops that can use sort of the higher bandwidth of the 5 gigahertz spectrum. Now scrolling down here to user group, if you remember the last video, we set up a bandwidth throttled user group called Crosstalk Guest. I'm not going to be throttling this IoT network, but you can if you want to. So for me, these IoT devices use very little bandwidth anyways. Usually they're just sort of pinging out to the internet. And other devices that are connected to the network, like my Home Assistant Raspberry Pi here, I would want that to have full speed because sometimes it has to download updates and stuff, and I don't want to slow down that process by throttling it. Okay, so we're going to leave everything else default, and then we're going to click Save down at the bottom. So now we can see that we have the Crosstalk IoT wireless network. We also have the Crosstalk IoT wired network. Now this computer that's right behind me, we're going to now put this computer wired into the IoT network. So it is plugged into port 7 on the 24 port switch that I have in the cabinet. So let's go to our devices. We're going to click on our USW Pro 24. We're going to choose port 7 and we're going to edit this port. Now again, this has to do with VLANs. What I'm doing here is I'm going to change the switch port profile from all. When it's in all, it means our main LAN is the main LAN of this port, but we also have access to the other two networks, VLAN 10, the guest network, and VLAN 20, the IoT network, if the device that's plugged into that port is tagged to read those other networks, like a voice over IP phone might be or something like that. But since this computer that I have back here as a test does not understand VLAN tagging, we are going to manually set port 7 into this IoT network, meaning that anything plugged into that port natively will receive an IP address on the IoT network, or 192.168.20.x. All right, go ahead and apply that change, and the device is provisioning. As soon as this has finished provisioning, we're going to take a quick look at this computer back here. All right, so the switch has finished provisioning, and you can see that I was pinging out to the internet, and now I'm getting request timed out. Let me go ahead and start recording this screen. And if we come over to our command prompt, let's get out of that ping. We're going to say ipconfig/release, which is going to release the current DHCP lease, and then we're going to say ipconfig/renew. And now we can see that I received an IP address of 192.168.20.222, meaning that now we are in the IoT network. So if I ping back out to the internet, we can see that I'm receiving replies from 1.1.1.1. If I ping an FQDN, such as /dot.org, we can see that I'm also receiving replies, which means that DNS is working and the internet's working. However, remember this is our IoT network. So what else might be working that we don't actually want to be working? Well, if I ping 192.168.1.1, I'm getting a reply from the main LAN interface of our UDM-Pro as well. my computer here is 192.168.1.144. And I'm also receiving replies from my main computer here as well, which we don't want, right? We don't want my IoT devices or devices that are in the IoT network to be able to see computers that aren't in the IoT network. So let's go ahead and start a persistent ping from this back computer over to my main computer. And now we can keep an eye on this as we do our firewall rules, which we're going to do next just after this word from our sponsor. This video is brought to you by our Crosstalk Solutions turnkey hosted or on-premises PBX services. If you're looking for a technology partner to help painlessly transition you to a brand new PBX, then look no further than Crosstalk Solutions. We offer full turnkey PBX installations where we work with you on the design of the system, perform a complete setup and test of the PBX and all equipment, and then ship everything to you ready for plug-and-play installation. Once you receive the equipment, we'll guide you through the transition to the new system, provide user guides and training material for your users, provide administrative training for your administrators, and we also include 30 days of post-deployment support with no ongoing monthly maintenance fees. We will also ensure to set up your PBX with best practice Kerry's Law and Ray-Baum Act compliant E911 emergency dialing, as well as guide you through the phone number porting process if you're switching phone service carriers. We have truly designed our turnkey PBX process to be as painless as possible because we know that switching PBX systems can be a daunting task, but it doesn't have to be when you choose Crosstalk Solutions for your voice over IP needs. So check out crosstalksolutions.com for more information on our turnkey PBX packages, and when you're ready to get started, just fill out the contact form on our website or email info@crosstalksolutions.com for a custom quote within 1 business day. All right, now back to the video. All right, thank you so much for that, and now into the firewall rules for our IoT network. So to get to our firewall rules, we want to click on Routing and Firewall, and then click on the Firewall tab right here. So let's talk about all of these various tabs here. We have WAN in, WAN out, WAN local, and then the same things for LAN as well as guests. So essentially, these are the directions that traffic can be flowing within our network. So let's take a look at the 3 LAN tabs. LAN in means here's my UDM-Pro. This is all traffic that is coming into the LAN interfaces from my LAN networks, right? LAN out means any traffic coming from the UDM-Pro or anywhere else into the LAN networks. And then LAN local means anything that originates from my local area networks and then is destined for the interface of the UDM-Pro itself on whatever LAN we happen to be coming from. So that would be my IoT network of 192.168.20.1 or my main LAN network of 192.168.1.1. If we click on LAN in, we can see that that has our 2 networks already in here, 192.168.20, 192.168.1. If we click on guest in, we can see that has my guest network subnet of 192.168.10.0. All right, so we're mainly going to be focusing on the LAN tabs here. And the first thing that we want to do is to create a rule that allows for any established or related connections to proceed through unhindered, if you will, right? So if anything's already an established connection, established means traffic is flowing on a connection that's already been established, and related means it's a new packet but from a connection that's already established. So we're going to say create new rule, and we'll say allow established and related. We're going to accept all traffic, and then down here under advanced for states, we want to check the boxes for both established and related. And then for source and destination, we're going to say any, right? We don't care, just any established or related connections. Let's allow those through the firewall. And we'll click Save. Now, these rules are processed in order. So as we're adding rules, they're going to go each one underneath the next. So when you're adding rules to the firewall, you kind of want to think through like, okay, well, which rule do I want to catch before I move on to the next rules, right? And you can always reorder everything once you're done if something's not working the way that you want it to. The next rule that we're going to create is for our LAN network, 192.168.1.1. That network is going to have full access to see all of the other networks, right? So we don't care if we're in our secure LAN. The secure LAN can see stuff in the IoT network, such as if you wanted to get access to your Home Assistant, Raspberry Pi. It can also see devices in the guest network, right? So let's go ahead and create a rule for that. But before we do that, we want to create a group that encompasses all of the RFC 1918 private address spaces, because we're going to say our LAN can see all of the other networks, right? Any private address space. Now, we could individually add our networks, but by using a group instead, we're basically saying it's a catch-all, right? It's a catch-all for any rules that we create. You'll see what I'm talking about in just a second. So let's click on Groups, Create New Group, and we're going to call this Local Networks, and then we'll also call it RFC 1918. This is going to be an address group, and we're going to give it 192.168.0.0/16. That basically means any private IP address range 192.168 anything.anything. And we're also going to add two more. So the other RFC 1918 private address spaces that are not routable on the internet, they're reserved for private subnets, are 172.16.0.0/12, as well as 10.0.0.0/8. And we're going to save that group. Basically, we just created a group that says any private network, right? It allows us to use that group in our firewall rules. So now let's go back to our rules. We're going to click on LAN in, and we want a rule that says our main LAN, 192.168.1.x, can see anything in any private address space, right? So we're going to say create new rule, allow LAN to anywhere. And we're going to click accept, scroll down, and then our source is going to be network, and we want to select our main LAN. And the destination is address or port group, and then that group that we just created. So we're saying if the source is the LAN and the destination is any private IP address space except that connection. Save that rule. And now let's create another rule where we are going to block everything else, right? Any other inter-VLAN communication from any private address space to any other private address space, we are blocking. Right now, remember, these rules are executed in order. So for our LAN, any traffic originating from the LAN is never going to hit this third rule because it's going to be caught up in the allow LAN to anywhere rule. So let's create our new rule. We're going to say block inter-VLAN traffic. And we're going to say drop connections. This time we are not accepting connections, we are blocking connections. Scroll all the way down where the source is any RFC 1918 network, private network, and the destination is also that same group. So any private network trying to get to any other private network, we are blocking. And remember, the LAN rule is above this one. So if we're coming from the LAN, we're already authorized. You'll never actually hit this rule if you're coming from the LAN. So let's go ahead and save that. And then typically firewall rules are applied almost immediately. You might be saying, well, Chris, your firewall rule was applied, but I've got this persistent ping running back here from this computer in my IoT network that's pinging my main computer in the LAN network. Well, you just created this firewall rule that blocks that. Why is that still allowed to ping? Because the first rule that we created was to allow established and related connections, right? And this is already an established connection. If we come over here to settings, we can see that the timeout value, the state timeout value for ICMP, which is the protocol that ping uses, is 30 seconds. So basically, if we stop this ping and then we wait 30 seconds, we're going to try it again. All right, so let's wait that 30 seconds and I'll be right back. Okay, so I think I've waited a good 30 seconds. Let's go ahead and try it now. We're going to run that same ping command, and now it's not working. Okay, so now we have successfully blocked all inter-VLAN traffic. being that this computer's in 192.168.20 trying to get over to my other computer here in 192.168.1, which is in my main LAN. But there's still some problems here, right? So the device is in my main LAN, but we still do have access to a couple other things. Let's take a look. So I can ping 192.168.20.1, okay, so the UDM interface of my IoT network. I can also still ping 192.168.1.1. Okay, so I can still ping the UDM-Pro interface for my LAN network, because that's not a LAN in rule, that is a LAN local rule, and now we need to create some rules to prevent this from happening, because right now, if I'm in my IoT network, I can open up Chrome and go to 192.168.1.1 and bring up the interface of UniFi OS, right? Which I don't want to be able to do that from my IoT network. I don't want devices in the IoT network to have any access to this UniFi interface whatsoever. All right, so let's do some blocking there. The first thing that we're going to block is my IoT network and my guest network's access to other networks' gateways. And to do that, I need to create some more groups. So back on my main computer here, we're going to click on Groups, and we're going to create a new group. This is going to be an address group, and we're going to call this block, oops, wrong keyboard, block IoT to GW, gateway, right? And the addresses that we're going to block are 192.168.1.1 and then 192.168.10.1, the address of my guest network, and we're going to hit save. Then we're going to add one more that says block guests to GW, gateway again. And we're going to block 192.168.1.1, and we're going to add and block 192.168.20.1, my IoT network. So what I'm doing here is for my guest network, I'm blocking the main LAN and the IoT network. And for the IoT network, I'm going to be blocking the main LAN and the guest network. And we're going to save that. And now let's go back to our rules, and this time we're going to click on LAN local, and we're going to add a new rule. And in this rule, we're going to say block IoT to gateways. We're going to drop connections, and we're going to drop any traffic where the source is the IoT network and the destination is the rule that we just created, and we're going to save that. Now let's add another one for our guests, block guests to gateway. We're going to drop all connections where the network is our guest network and the destination is guest to gateway, right? So save that. And now we have successfully blocked the IoT network from seeing any other network interfaces. So let's test that out. So I've refreshed the page that I originally brought up the UniFi OS, and we can see that it is just spinning and spinning. It is not actually coming back with that page. And if I try to ping 192.168.1.1, now I get no reply whatsoever because I am blocking that network. But still, we're not done yet, right? Because even though I can now no longer get to the UDM interfaces of my other networks, from the IoT network, I can still get to the UDM interface of the IoT network. Let's take a look at that. So if I say ping 192.168.20.1, it's still replying. And if I open up UniFi 192.168.20.1, I can still get to the GUI interface of the UDM-Pro. You might say, well, Chris, why don't you just block 192.168.20.1 from the IoT network? Well, if you did that, you'd no longer have internet access. So what we need to do instead for our third rule is only block the access ports required for the interface of the UDM-Pro, which is going to be HTTP, HTTPS, and SSH, right? So port 80, port 443, and port 22. All right, so back on my computer, the way that we're going to do this is we're going to create two more groups. So we're going to click on Groups. We're going to create a new group, and in this group, we're going to call this All Gateways.
which is basically all interfaces of my UDM-Pro. And we're going to say 192.168.1.1. We're going to say 192.168.10.1 for the guest network, and 192.168.20.1. And we're going to save that group. Now, those are the gateways. We also need to add another group, so create new group. This time it's going to be a port group. So we're going to call this UDM-Pro access ports. And the ports that we're going to add are 80 for HTTP, 443 for HTTPS, and 22 for SSH. And let's go ahead and save that. And now we need to add another rule. So we're going to go back to Rules IPv4, click on LAN Local, create a new rule, and we're going to say block IoT from UDM-Pro access. We're going to turn that on. We're going to drop everything where the network is IoT and the destination is our gateway IP address group that we just created and the ports that we restricted. So we're going to save that. And now if we go back to the back computer here, I should still be able to ping the interface 192.168.20.1. Yep, I can still ping it. And if we wanted to, we could block ICMP. But I like using ICMP for testing stuff, right? So I usually leave ICMP enabled. But if I bring Chrome back up and try to browse HTTPS to the interface 192.168.20.1 that was working just a second ago, now we can see that it's timing out. From the IoT network, I do not have access to HTTP, HTTPS, or SSH on 192.168.20.1 or any of the other gateway IP addresses 1.1 or 10.1. Alright, so there you have it for the IoT network setup and the related firewall rules. Now you can dig in a lot deeper and get much more granular with these firewall rules. For instance, another rule that you might want to add is the ability for devices in the IoT network or the guest network to see DNS servers such as a Pi-hole on your main LAN, right? You might want to allow DNS through or maybe disallow all other DNS servers besides those Pi-holes. Now that's going to be beyond the scope of this video series, but there's so much that you can do with these firewall rules. But it can also be pretty complicated and confusing at times. So if you have questions about any of this, put those down in the comments below and I will definitely look those over and answer whatever I can. If you like this video, make sure you give me a thumbs up and subscribe to Crosstalk Solutions for more videos just like this one. Alright, we will see you guys in the next video.